Hello, boys and girls. We're on Chapter 8, Lesson 3. Multiply a fraction by a whole number using models. Okay, so we're going to multiply a fraction by a whole number. And we're going to use some models. I bet in class today you looked at all types of models. You may have even used some fraction strips or fraction circles, right? And you actually saw all of those models, right? So let's just look at number 4. Now you don't have the directions on here, but because I cut them off, but the directions say multiply. That's all it says. Okay, so you know that multiplication is sets of or groups of, right? So in number 4, we have 3 times 5/12, or 3 groups of 5/12. So if you wanted to use a model for that, you could do, twelfths are kind of little, aren't they? Well, compared to half or something, right? 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, see now, using models, drawing models, kind of annoying. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so those are twelfths. And we have 1, 2, 3, 4, 5. So I just drew a model of 5/12. Now, I have 3 sets of those 5/12. Okay? You can just visualize the other 12s. Dun, 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 dun. But we're not talking about those. We're talking about these first 5/12, right? 1, 2, 3, 4, 5. And then a third set of 5/12. Okay? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so how many twelfths do we have? We have 5 here, 5 here, and 5 here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15 twelfths, because in each of these we were working with twelfths, right? With fraction pieces that were 12th size, and we didn't change that, so the answer stays twelfths. We have 15 out of 12 equal parts. Okay, so that's a fraction greater than 1, isn't it? All right, let's look at number 5, and instead of drawing a model, I'm going to use some repeated addition, which is another sort of kind of model, right? So number 5 says 6 times 3/4. So we have 6 groups of, I didn't do that well, groups of 3/4. So here's 3/4 plus another 3/4 plus another 3/4 plus another 3/4 plus another 3/4. 1, 2, 3, 4, 5 plus another 3/4. What does that equal? Well, remember this model over here? Let's count how many pieces. Okay, there's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 pieces. Did we change the denominator? No, we didn't change. That 4 still makes a whole. 4 equal parts still makes one whole thing or one set, right? So 6 times 3/4 is 18/4. Now I bet in class, you guys, I'm going to rewrite 6 times 3/4. I know that you talked about the fact that you could say, okay, I have 6 sets of 3. Because in both of these models, we did the whole number set of the numerator, didn't we? 6 sets of 3. 3 sets of 5. 6 sets of 3. 6 times 3, that's 18/4. All right? Let's keep going. All right, this is number 11. Now I'm sure that you have done all of the rest of the ones you needed to do on that page. Okay, let's look at number 11. Emily uses 2/3 cup of milk to make 1 batch of muffins. How many cups of milk will Emily use if she makes 3 batches of muffins? All right, let me check this again here. I'm rereading. That's what I do. Emily uses 2/3 cup of milk. So she had a cup of milk divided into 3 equal parts, right? She uses 1, 2. We'll put a little handle on it too, right? A cup of milk. Okay, so that's what she uses to make 1 batch of muffins. She uses 2/3. How many cups of milk will Emily use if she makes 3 batches of muffins? Well, let's see. That's for 1 batch. That's 2/3. Of course, then we have the second batch. Okay, doodaloo, doodaloo. A little handle. My handles kind of look like ears, don't they? Second batch of muffins. That is another 2/3. Third batch of muffins. Little handle ear. Third batch is another 2/3. So Emily will use, what are we going to do here? Count the parts. 2, 4, 6. 6. Denominator didn't change. 6/3. I don't have room to write cups there. Cups. Right? So here's how we would write that. As a whole number times, oh goodness, I meant to write a 2. Times a fraction. 3 times 2/3. That is like the worst 2 ever. Hold on. There we go. 3 times 2/3. 3 times 2 is 6/3. Beautiful. All right, now we have flipped to the back to the lesson check. Number 1, Alita's puppy gained 3/8 pound each week for 4 weeks. Altogether, how much weight did the puppy gain during the 4 weeks? All right, so let's see. I'm going back up here and reading about this puppy. I bet it's adorable. Okay, Alita's puppy gained 3/8 pound per week or each week for 4 weeks. Altogether, how much did the puppy gain during the 4 weeks? So 4, right, sets of 3/8. Each of the 4 weeks, 3/8 pounds was gained. Okay, so looking at those choices. Oh, do you see one that you can eliminate? A, B, C, D. Look at those 4 choices. Which one do you know is incorrect right now? Can you see it? Ringy ding ding. It is not going to be A, because it didn't say anything about in here about Alita changing how many parts make the whole, right? No. So it's not going to be A because that denominator is different. So let's see here. 4 sets of 3 parts of a pound. I forgot what they were talking about for a second. 4 sets of 3 parts of a pound. 4 times 3 is 12 equal parts out of 8 that make a pound. Okay, so that little puppy gained 12/8 pounds in 4 weeks. All right, let's keep going. Now we're down here to review. We're going back to chapter 7, lesson 9. Okay, let's see here. Well, it looks like Albert Einstein wrote these answers, but we can handle it. Lance wants to find the total length of 3 boards. He uses the expression 3.5 plus 2 plus 4.5. Okay, so each of those numbers must be a length of a board, right? Because he has 3 boards. So board, board, board. How can Lance rewrite the expression using both the associative and commutative properties of addition? Okay, so how can he rewrite the expression? So guess what, guys? We don't even have to solve this. We just have to rewrite it, okay, using both the associative and the commutative. Well, let's look at our choices. Well, you know what? Before we do that, let's remind ourselves of what these properties are. Associative. I always talk about like business associates, people who are like, yeah, how you doing? How you doing? My name's Jack. My name's Samantha. Okay, there's just an example. 4 and 2 are in parentheses. And since we're adding all the way across, I can associate 2 and 1 by changing the parentheses. I didn't change the numbers, and the operation is addition all the way across, right? Addition, addition. So that's the associative property. I can change which numbers I add first, and the sum will be the same. All right, so then let's think about our friend, the commutative property. The commutative property, that is the one where 4 plus 2 equals 2 plus 4, right? And remember, Mrs. Olvey says, commutative, commutative, commutative. And then I say, turn your head sideways. I'm turning my head like to the right. And when I go, woo, woo, what letter is that? That's the letter C. Commutative, commutative, the letter C for commutative means that I can add 4 plus 2 or 2 plus 4, and the answer is the same. 6 equals 6. All right, so let's look at these choices. Choice A has 5 plus 4 and 1/2. Now, they're not using the associative property because nothing is in parentheses. So choice A, you get the X. Let's look at choice B. 3.5 plus 2 plus 4.5. Okay, and let's look at this original one. 3.5 plus 2 plus 4.5. Well, the number, they moved the parentheses, didn't they, boys and girls? So they used the associative property. But they did not use the commutative property, did they? All of those numbers are in the exact order. So they only used one of those properties. And it says they want you to use both associative and commutative. So choice B, you are out. Let's look at choice C. 2 plus 3 1/4 plus 4.5. All right, so let's look back at the original problem here. 3.5. Aha. Okay, so they flip-flopped, zoop, zoop, commutative, commutative. The 3.5 and the 2 have been flip-flopped, right? Switched, the position has been switched. So different numbers are inside the parentheses. Okay? Ding, ding, ding. So they use the commutative property by changing the order of the numbers being added, and they use the associative property by changing which numbers are added in the parentheses. All right, so it's got to be C. But you know what? I'm going to take a look at D. D, 3.5 plus 4.5 plus 2. Now I'm looking back up here at the original problem again, up here, okay? And, oh, okay, I see what they did. Look in the parentheses up here. They used the commutative property inside the parentheses, but they didn't change what was in the parentheses. So they only used the commutative property. So final answer, C. All right, you guys, great work.